All right, good morning, everyone. Thanks for being here. This is the February Water Conditions Monitoring Committee, February 2025, I should add. My name is Emily Adrid, and I am at the Colorado Water Conservation Board. And so this morning we have presentations from the NRCS and the Colorado Climate Center. But before that, I am going to do a short presentation to review the state's drought response plan. I see some folks have already been doing adding their name and affiliation to the chat. So thank you all for doing that. So if you haven't done so already, please go ahead and add your name and affiliation in the chat while I share my screen. Okay. Slideshow. All right. So thanks again, everyone, for being here. This morning, I'm going to review the state's drought response plan. We are going to start making this probably an annual presentation at the WCMC so that we're all reminded of the processes that happen should the state enter into a severe and widespread drought. So we got to start with the history. The history of the Colorado Drought Response Plan is rooted in our state's Enhanced State Hazard Mitigation Plan, which is coordinated and led by the Colorado Department of Homeland Security and Emergency Management. So yeah, the ESHMP, as I'll refer to it, lays out a very comprehensive mitigation and response plan to all the hazards that our state faces. And it's updated every 5 years. So in 2018, it was updated, or before 2018, the state's drought response plan and the flood response plan were separate documents. But in 2018, the flood mitigation plan was folded into the ESHMP. And then in the last update in 2023, the drought response plan was also folded into the body of the ESHMP. And there were also some modifications made to our drought response plan. And I will put a link in the chat to the ESHMP following the presentation. Okay, so sorry for the poor image quality, but this is the 2018 drought response framework. And the big triangle there is the drought task force, which included the WCMC, or at the time, what was called the Water Availability Task Force. All of these sectoral-based task forces, and then the lead agencies, or the WCMC agency partners. However, in practice, the drought task force didn't work like this. All of these different entities didn't work together. So we wanted to better, in the 2023 update, we wanted to better define the WCMC and its agency partners, the drought task force, and then ad hoc work groups in a clearer way. So this is our current drought response framework that was included in the 2023 update to the ESHMP. As we know, the Water Conditions Monitoring Committee is in charge of monitoring our state's water, drought, and climate conditions. We meet once a month, and this meeting is open to the public. And CWCB facilitates this group with support from the Division of Water Resources. And we also have our agency partners. So our agency partners include the Department of Local Affairs, or DOLA, the Department of Homeland Security and Emergency Management, or DHSEM, the Colorado Department of Agriculture, or CDA, and then DNR, or the Department of Natural Resources, which encompasses both CWCB and DWR. So when drought conditions worsen, staff representatives from each of these agencies will be called upon to convene and recommend and support the drought task force activation. So the drought task force is made up of the WCMC agency partner directors and senior leadership. The role of the drought task force is to communicate recommendations to the governor, who may provide additional assistance. And the drought task force is also in charge of convening the ad hoc work groups to better understand the local, regional, or sectoral impacts of the current drought. So, for example, if drought was really bad in the Southwest region for many weeks and months, it was really impacting agricultural community, then the drought task force might convene an ad hoc work group and reach out to the local leaders in the region that are being affected, and talk with them about the appropriate response measures. So they are also responsible for sharing information from the WCMC meetings to the ad hoc work groups and the Gov's office. To provide a little bit more context for the ad hoc work groups, they are made up of members of the drought task force and local, regional, and/or sector-based leaders impacted by drought. The role of convening this group is to better understand, evaluate, and elevate the local drought impacts to inform any response actions that might need to be taken. These work groups are time-bound and topic-specific. So the work group could meet once, and they might be able to work through the appropriate response measures, or, depending on the conditions of the drought, they might need to meet multiple times based on their need. So the goal is for these groups to be flexible to the local needs and impacts. Finally, we have the Gov's office. They are responsible for coordinating the drought task force with the drought task force to provide any state level drought support and relief. They have the power to declare a 30-day disaster emergency, and they can also seek federal assistance or request a federal drought declaration if needed. So this is the simplified drought response framework that's included in the 2023 drought response plan. So that is all I have today. I know this was pretty quick. And again, I'll put the link to the eSHMP in the chat where you can find more details about the drought response plan. So with that, thank you very much. And I will take any questions that there might be before we hand it over to Peter. All right. Cool. Well, then I will hand it over to Peter. If you have any more questions, feel free to put them in the chat. And Peter, you are up.
All right. Thank you so much, Emily. Can you hear me all right?
Yes.
Okay, I'm going to go ahead and share my screen. Let's see here. So you should currently be seeing a Google window that shows current ENSO conditions. That's fine. I'm going to replace it with my slides in just a minute. And now you should be seeing the slides. Are you seeing the slides?
I'm still seeing the ENSO
Huh.
page.
Okay, interesting. Let me see if I can fix that. How about now?
Yep, there you go.
Okay, I apologize for the delay there. Thanks
No
everyone
worries.
so much for being here this morning. Welcome to the regular climate update for the Colorado Water Conditions Monitoring Committee, February 25th, 2025. What a cool date, 2/25/2025. Today we're gonna go through a pretty standard agenda. We'll start with a look at current seasonal climate conditions, looking largely at the last 3 months, but a little bit at longer time scales when relevant. We'll talk about some of the notable events that we've experienced, give an update looking at the US Drought Monitor, as well as some land surface model drought monitoring products. And then we'll talk about the seasonal forecast and how the spring might be shaping up. And from that point, we'll hand it over to NRCS to give us the update on how the snowpack and water year-to-date precipitation is building up in the Colorado High Country for the 2025 season. All right, we're going to start with one of our quadrant charts. You will see a few of these, so I'm just going to go over a couple of the details here. We are looking at Colorado statewide average temperature and precipitation conditions for January. This is using the National Centers for Environmental Information NCLIME Grid product, which is a 5-kilometer resolution reanalysis of our climate data going back to 1895. The backbone of this data set is the Cooperative Observer Network weather stations, which are really the backbone of our understanding of climate from a temperature and precipitation standpoint across the country. Now, the horizontal axis here is the accumulated precipitation for the month, and the vertical axis is the average temperature. And each dot represents a year from our past throughout the length of time captured by this data set. And the star shows where we were in 2025. So it was a much cooler than normal January in 2025, as you can see by how much lower it is than that crosshatch line that shows the average temperature for January. It was 6 degrees below average statewide. And that was the coolest January since 2007 statewide. It was also a little bit on the dry side, so 0.35 inches of precipitation below normal, but January, at least average statewide, is one of our drier months. Having said that, it's still crucial because it's not one of our drier months for parts of the high country, which is where our high elevation snowpack and much of our water comes from. Okay, here's a look at how that breaks out spatially, looking at temperatures for January 2025 versus the full time series. If you read the bar at the top, it says it was only 3.4 degrees below average, but we're comparing apples and oranges there. So on the last slide, I was giving that 6 degrees below average for the 1991 through 2020 average, but that is showing it's 3.4 degrees below the 20th century average, which is in a sense significant because the long-term trends have been towards warmer conditions in every month. And while it is easier to kind of break away from that trend in winter and spring, where we have more year-to-year variability, it's not that often anymore that we see months that are significantly below the 20th century average, just since our trend has been towards warmer conditions. And as you can see, it was actually one of our 10 coldest Januaries for a number of locations across the state, including parts of our high country in northern and central Colorado, parts of the near Colorado Springs and Pueblo, like El Paso and Pueblo counties, and to the west of there in areas like Keller and Fremont County, and all the way down the east side of the Continental Divide. Okay, here's a look at that time series of average temperature. So this is kind of what I was talking about on the last slide or two with, for one, yes, definitely one of our cooler Januaries recently. So if you look at that last point on the time series, you'll see that it's below the number of points before, coldest since January of 2007. But you can also see that particularly since the mid to late 70s, there is a bit of an upward trend, but because there's a little bit more year-to-year variation in winter and spring, that trend is a little bit more masked than we would see in one of our summer or early fall months. Okay, here's how things looked from a precipitation standpoint statewide. Like I mentioned, it was below normal overall, both below the 1991 through 2020 normal, as well as our 20th century average. The biggest take-home message here is that the lack of precipitation to the west, kind of on our west slopes, led to some degradation of drought conditions, whereas the wetter than normal conditions east of the Continental Divide led to some additional amelioration of drought conditions. Things have been kind of going that direction in general recently, with the west getting drier and east of the Continental Divide starting to become a little bit more drought-free, as we'll see on the U.S. Drought Monitor map in just a little bit here. Let's see, it was the first time that the Montrose #2 station, which has been around since 1896, had no precip in January. So that's part of the area that we're seeing that was record dry in parts of Mesa and Montrose County. Here's a look at the time series for precipitation. And you can see we're a little bit on the drier side than normal, but certainly plenty of interannual variability for the month of January. Driest actually since 2015, though, which surprised me a little bit. Okay, this is looking at our month of February to date. And again, I've just got to be really careful to make sure we know what time scales we're looking at here. So this is looking at departure from normal temperatures, where the normal is the 1991 through 2020 normal, so more recent normals. And this product comes from the High Plains Regional Climate Center, and their mapping product here, again, is using Cooperative Observer Network data, but it's not exactly the same data source as what I've been showing so far. Big take home here is that it's been cooler than average for February east of the Continental Divide, warmer than average west of the Continental Divide, and then I guess the San Luis Valley is east of the Continental Divide. The Rio Grande also ultimately feeds into the Gulf, not the Pacific, but the Rio Grande has been much above average in terms of temperature. And one of the main reasons for that is lack of snow cover. So if we were to look at a snow cover map for the state of Colorado, in general, the San Luis Valley has lacked snow cover in the month of February, whereas they normally do have snow cover. And when you have snow cover in the winter, more of the sun's energy during the day is reflected by that reflective white surface than it is by a snowless brown surface, as well as a snow-covered surface, especially a freshly snow-covered surface, more efficiently emits infrared radiation out to space at night, so it cools down more quickly and more deeply. Conversely, the opposite's been true in northeastern Colorado, where not only have we had a couple really big shots of cold air, but we also have had more persistent snow cover in that area than normal. Okay, here's a look at a couple notable events for the month of February so far. In general, February has been characterized by statewide near normal temperatures, but certainly some huge variation spatially, like we showed on the last slide, and some huge variation temporally, like we're showing here and we will on another slide. So here we're looking at daily temperature conditions for the Grand Junction Walker Field Station. Horizontal axis gives you your date, so it's the month of February to date. Vertical axis shows temperature. That brown band in the middle is kind of your normal daily high and low temperature range for Grand Junction. The blue line and the red line show the records for each day, and then the blue bars show the daily highs and lows this year. And you'll notice from February 3rd through February 8th, we had record warm, high temperature conditions in Grand Junction, and they were not the only area that experienced a record warm spell. So this is a map of our high temperatures from the Colorado Agricultural Meteorological Network on February 3rd, 2025. And we can see these, what you would think of as warmer than normal temperatures across nearly the whole state, with a lot of our area along the Front Range getting into the 70s, up into the 60s and 70s on the west slopes, where that's actually less normal than it is for the Front Range this time of year. It's not normal either place, but it's harder to do on the west slopes where you don't have the same probability of dry downslope winds warming things up. And then if you look at the Arkansas River Valley, you see some of the warmest temperatures in the state on February 3rd, as much as the upper 70s or even 80.8 down in Walsh. Having said that, if you look at the northeast corner of the state, there was an area where we stayed a little bit cooler. And then this is a table from a recent blog post that Ali Mazarek in our office put together. I would recommend checking it out. It's on our website, looking at some areas that broke records during this warm spell. And the areas highlighted in red are areas that had a new record winter temperature. So the highest temperature ever experienced in December through February at that station. Alamosa Bregman Field's record goes back to the 1940s, I believe. So they set a new record all-time high winter temperature. Ridgeway, I'd have to check how far back that record goes, but new record high temperature, as well as Colorado National Monument, and certainly a bunch of daily records across the state. Now, this is the look at kind of the flip side. This is Akron on the Eastern Plains. And again, we're looking at daily temperatures for the month of February. And here we see that overall, yes, it's been a little bit cooler than normal. In fact, quite a bit cooler than normal for Akron for the month of February, but huge variability around the mean. So again, that brown band is your average temperature range. And you see we've gone way above it twice now and way below it a couple of times, including on February 18th. You can see the daily high temperature for Akron was below 0 Fahrenheit. And that was true for a number of stations across Northeast Colorado. This is a map of our daily maximum temperatures for February 18th, 2025. I was talking to a reporter in Telluride this day who was asking me why it feels like spring already. And as you can see on the west slopes, it did. So for her experience, it certainly did. But east of the Continental Divide, we were dealing with a cold air mass. Here's a look at percent of normal precipitation for the month of February, at least through the 21st or a couple days ago. Overall, wetter than normal for the northern portion of the state, drier for the southern portion of the state. The map on the lower left is just a little bit different product from the climate toolbox. I believe that does use the Incline grid product, but it's looking at the last 30 days. So it includes the end of January as well, where the greenish areas are above normal, the browns are below normal. So both products showing a similar story. We have had a couple of major snow events in February. We did see an event in the middle of February that I'm sure NRCS will talk about more, where the San Juans made up some ground, with some areas in the high country getting as much as 2 to 4 feet of snow. And then that snowfall kind of continued into the next few days for the northern Rockies. And there were areas of Summit County, as well as further to the north, that measured as much as close to 4 feet of snowfall from February 13th to February 19th. These are just a couple maps showing southwestern Colorado and north central Colorado, some of our community collaborative rain, hail, and snow network observations for these time periods. And then we had a significant snow event in the Denver metro area just last Friday, or Thursday into Friday. And as you can see, the DIA station, only 0.6 inches of snowfall, very poor representation of what's going on over. Actually, I'm not sure if that's the DIA station, but just a little bit to the north and west of the DIA station, actually 0.6 inches. DIA was also a poor representation of what was going on across the area of Denver where most people live. And then where most people live, somewhere between 4 and 8 inches, up in Conifer, as much as 21 inches of snowfall. So a couple fun snowfall events this month as well. Okay, now I'm going to use a couple slides just to look at the last 3 months. So we're looking at the last 3 full calendar months here, so November through January. And again, here's one of our quadrant charts showing precipitation on the horizontal axis and temperature on the vertical axis. And you can see that star for 2025 almost smack dab in the middle there. A little bit cooler than our 1991 through 2020 normal, and a little bit above normal in terms of precipitation, but just barely. So if we put all the weather we've been experiencing in a blender, average it statewide, then we see pretty normal conditions, although from place to place, local conditions certainly may vary. Here's a look at how things broke out spatially for November through January statewide. We also wrote a blog post about the colder than normal air in Gunnison, where we locked in some above normal snow on the ground early in the season and ended up with some cooler than normal air earlier on in our winter in Gunnison in November and December. You can also see a little bit of a cool spot showing up in Park County. But then November through January, above normal temperatures on the Eastern Plains, that's certainly reversed in February. And I suspect when we look at the 3-month time series of December through February, you'll see a very different map where the cooler than normal conditions kind of kick out that warmer than normal footprint in Eastern Colorado. So here's November through January average temperature. We were just 0.8 Fahrenheit below the 1991 through 2020 normal, a little bit above that longer term average, where you can see a little bit more clearly on this slide than just January, the trend since the late 70s, particularly since the late 70s, early 80s. Okay, here is a look at how things broke out spatially by precipitation for those 3 months. And again, one of the big stories going on right now is conditions worsening in southwest and western Colorado, whereas conditions have improved from a drought standpoint in eastern Colorado. Now, this includes the influence of our November blizzard in eastern and southeast Colorado, where there were areas that got 4 feet of snowfall, not even necessarily in the mountains, but also extending out onto the plains a bit in November 5th through November 9th. And then here's the time series for precipitation, but again, we're looking at November through January. And like we showed in the quadrant chart a couple slides ago, pretty near normal, just 0.717 inches above normal statewide. All right, and then here's just the last 12 months. So this is the last 12 full months, February of 2024 through January of 2025. And so if we look on a longer time scale, we certainly see warmer than normal conditions, and in fact, still top 10 conditions throughout much of the state. You're going to see some of this come down a little bit once we look at March through February, including the influence of this cooler February on the Eastern Plains. But again, that's just 1 month in 12 with this, this graphic. So things will still show warmer than normal. And then this is looking at the last 12 months precipitation-wise, particularly last May and last June, we had some anomalously wet conditions in the San Luis Valley. You see the influence of that here. Much of the state within the long-term historical average range for precipitation. All right, so with that, I'll move into the drought update. I've definitely hinted at this with the precipitation slides, how we've seen drought development in western Colorado, amelioration in eastern Colorado. Better than normal top meter soil moisture across most of the state. I'm going to be interested to talk more about that because this is the time of year that we get really interested in what's going on with antecedent soil moisture conditions before the runoff happens, because in some past years, we have seen where below normal soil moisture has maybe had an influence on the runoff we experience in spring. Okay, this is a look at the most recent US Drought Monitor map. Well, I guess there would have been, there will be another one released in 2 days. So look out for that from the US Drought Monitor on Thursday morning. But this is the one that was issued on Thursday, February 20th, based on data through February 18th. So this is based on data from through a week ago. And you can see that most of the west slopes and southwestern Colorado are at least showing abnormally dry conditions, if not moderate drought or some severe drought creeping in the southwestern Colorado, kind of on the south end of the San Juans. Still some long-term drought remaining on the northern Front Range and extending a little bit out onto the Northeast Plains. But for the most part, things have been improving. This is how things have changed over the last 12 weeks or about the last 3 months. Areas in green are where you've seen improvements to the US Drought Monitor. Areas in yellow or kind of this more orange color are where we've seen degradations. The degradations have been out west. The improvements have been over the north central portion of the state as well as the eastern portion of the state. And then parts of eastern Colorado where you don't see any change, or areas where there was no drought 12 weeks ago on the US Drought Monitor, and there's no drought depicted on the US Drought Monitor now. And then this is the 1 year change, where you can see that a lot of that drought on the northern Front Range and kind of extending out into Weld County is drought that is new, at least as of the last year. And then we can see conditions actually last May and June, like I mentioned, improved in the San Luis Valley. But other than that, mostly we've seen degradation on the west slopes. Yeah, so this is a map of top meter soil moisture percentile as of February 20th, 2025, where the greens are showing above normal soil moisture and the yellows, browns, and even reds are showing below normal soil moisture. And this time series doesn't have as long a historical record as we'd like. It only goes back to the mid-2000s, but it's still nice to see soil moisture conditions in better shape than we've seen this time of year in some recent years. That could bode somewhat well for runoff, although there's some reasons to temper any optimism that I think NRCS will probably get into more. I think one thing that concerns me a little bit actually in Western Colorado is that some of these areas where you see high soil moisture in the mid-elevation range could be indicative of early melt. San Luis Valley being snow-free right now for the most part at low elevations. So that's from snow melting out. So this time of year, you do have to be a little bit careful with the narration when you look at above normal soil moisture. The Eastern Plains, however, I would say it's more of a good thing to be above normal this time of year. You're not guaranteed this persistent snow cover. It's not like there's usually 2 feet of snow on the ground and that's melted out or anything like that. You can have kind of transient snow cover on the Eastern Plains, but the fact that we have above normal soil moisture for the growing season across much of the Eastern Plains, I would say is a good thing. Now, local conditions may vary. This is not reflective of anyone's individual field, but sort of on a larger scale, this is what we're seeing with satellite retrievals of soil moisture. Okay, this is a look at terrestrial water storage. This is a newer product that I've started showing, and it's an integration of soil moisture data, as well as deeper groundwater, as well as snowpack and canopy moisture. Canopy moisture for most of the state is going to be negligible because we don't have a lot of canopy. But you can see that here things don't look as good. So for instance, across much of Western Colorado, you have some drier than normal conditions that are going to be largely influenced by lower than normal snowpack. And then on the Eastern Plains, you have some lower than normal groundwater conditions that are influencing the way this map looks. In general, this map still does have some things that we're trying to figure out. Like, I couldn't explain to you why it's red over the Denver metro area, over the Colorado Springs metro area. There's some strange things going on with metro areas. So if we paint with broader strokes, I think there's some useful information here, but again, not necessarily reflective of anyone's individual field or backyard. All right, that will do it for the drought update slides. Now we'll get into the spring summer outlook. I'm going to be talking mostly about spring, a little bit maybe about where models are hinting for summer conditions, but mostly what's coming down the pipe over first the next 7 days and 8 to 14 days, and then getting into the longer term conditions. So this is a map showing departure from normal precipitation forecast over the next 7 days. Areas in brown are areas with below normal precipitation forecast over the next 7 days. areas in green. There are no areas really in green that would be forecast above normal. It's looking like a dry week coming up is the long and short of it. And since normal precipitation this time of year is higher in the mountains, you see these deeper browns over the high country. And that's not meaning that there will be less precipitation in the high country than other areas over the next week. It just means that normal precipitation for the next week is higher, and we're not getting that precipitation. It is notable anytime the high country has a dry week this time of year because you're falling behind in terms of snowpack and water year-to-date precipitation, which are our kind of best metrics for forecasting runoff in the coming spring. 8 to 14 day time frame, it looks like somewhere around the middle of the first week of March, conditions are likely to change. It does look like there's potential for a pretty wet weather system. It's still a little bit early to know exactly where that might hit hardest. This could be more of an eastern Colorado system. It could be more of a northwest Colorado system. What I've seen in the weather forecast models looks a little bit less optimistic the further south you go, but we'll see what happens. Again, it's still a little bit early. And one thing that I'm seeing in the models right now is that this may be a little bit more of what we'd call a warm core event than we tend to see this early in March. So it's possible, and again, it's still early to know all the details, but it's possible that it could be more of a rain event than a snow event at lower elevations. Higher elevations, it'll be snow, if anything. Okay, so once we go beyond our 8 to 14 day time frame, our numerical weather prediction models descend into chaos, but we can still predict things better than random chance using statistical relationships between what happens in the atmosphere and slower moving components of our Earth's climate system, like sea surface temperature patterns. And so often we're looking at what's going on with the El Nino Southern Oscillation, or ENSO. You may have heard of El Nino or La Nina, and you may have heard that we're in a La Nina right now. We are still in a weak La Nina with cooler than normal sea surface temperature conditions persisting across the central equatorial Pacific. That matters because it has semi-predictable ripple effects on our atmosphere in the northern hemisphere. But this is a map actually showing sea surface temperature anomalies across the globe. And during a typical La Nina, you would see that those lower than normal sea surface temperatures over the central Pacific would extend all the way back towards Ecuador and the eastern equatorial Pacific. And they used to do so, but we're starting to see those cooler than normal sea surface temperatures be replaced by warmer than normal sea surface temperatures. And so it looks like La Nina is weakening. I look at this map and it doesn't look that much like a La Nina at all, but officially we still are under a La Nina. So I don't want to say it's not La Nina, but it looks like it's really breaking down. And that is important to note because most of what I show from the Climate Prediction Center leans pretty heavily into La Nina conditions or La Nina impacts persisting throughout the spring. So we'll see what happens there. But this slide is showing the relationship between ENSO and precipitation in Colorado by season. The areas in red are where El Nino tends to be wetter. Areas in blue, La Nina tends to be wetter. And again, it's broken down by season. The upper left is winter, or December, January, February. And then this upper right, which is really what we care about now, March, April, May, is springtime. So if we do hold on to La Nina conditions, or if we have kind of these lingering effects of La Nina, even as it breaks down, that's generally not good news for the state in spring, because La Ninas tend to be either more near normal or drier than normal. We don't see many of our above normal moisture spring times during La Ninas. We certainly see a reduced risk of a wet extreme during La Nina in spring. So if we do continue to have La Nina, or there are lingering effects as it breaks down, it could bode for a drier than normal spring. This is a graphic showing the odds of La Nina hanging around by season. So here the horizontal axis shows season, where that first tick on the horizontal axis is January, February, March. And then as you can see, 2 ticks over March, April, May is what we're looking at. And then the vertical axis shows percent chance of either La Nina, blue, neutral, gray, or El Nino, red. And we can see that La Nina is likely to give way to neutral conditions. We're not likely to see a rapid transition to El Nino like we saw in 2023. I think based on what we're seeing since these graphics are just a little bit dated, I think what we're seeing in the sea surface temperature patterns, that there's a greater chance of going over to neutral conditions even than what we're seeing here. I think it's likely that neutral conditions will officially take hold by sometime in the spring, which may help to bolster our chances of better precipitation a little bit. Now, with that in mind, here are the Climate Prediction Center's outlooks for March through May. And here we're looking at temperature on the left-hand side, precipitation on the right-hand side. If we look at temperature, areas in the oranges and reds are where we see an increased probability of above normal temperatures. Areas in the blue, increased probability of below normal temperatures. The darker the shading, the higher the confidence. Just because the shading is darker doesn't necessarily mean that temperatures will be more above or below average. It just means that the confidence in the statistical models is a bit higher. On the right-hand side, we're seeing the same thing for precipitation. And we see increased odds of below normal precipitation across the whole state for the spring. And I read their forecast discussion. This leans pretty heavily into La Nina conditions sticking around, or at least lingering effects of La Nina. I'm willing to buy that, at least in the short term. But as we get into later into April and even into May, I don't know how relevant La Nina will continue to be. It's gonna be interesting to see how different this map is at WATF WCMC next month. Old habits die hard. But anyway, right now we're going with increased odds of below normal precipitation. I do agree with kind of the increased confidence as you go further to the southwest, less confidence as you go to the northeast. But I think particularly on the eastern plains, where the bulk of your March, April, May precipitation comes in the second half of April or May, I think it's a little bit more risky to be confident in below normal precipitation. Now, as we get into April, May, June, or our kind of lead to forecast, we see in kind of an increase in confidence in warmer than normal, but a decrease in confidence in drier than normal. And then as we get into summer, increased confidence in warmer and decreased confidence in drier, but still a bit of that warm and dry signal sticking around, even into this June, July, August outlook. June, July, August, at this point, the outlooks are largely based on trend. So I think the increased confidence in above normal makes sense, particularly for summertime, where our year-to-year variability is lower. So if you have a trend towards warmer than normal temperatures, it's more likely that you will be warmer than normal. Okay, so that's about all I have. A couple takeaways. January ended much cooler than normal, 6 degrees below our most recent 91 through 2020 normal statewide. February will likely end near normal for temperatures statewide, but with large variability, both spatially and temporally, where we had a couple big cold snaps in the middle of the month, bookended by these warm conditions that we're experiencing now, and the warm conditions we experienced at the beginning of the month. Drought conditions are improving in parts of the state, but degrading in other parts of the state, particularly the west slopes. I'll hazard a guess that you're going to hear more about that in our next presentation. Weak La Nina conditions remain in the equatorial Pacific, but man, they are breaking down. So it'll be interesting to see how that impacts our spring. If La Nina remains in place, then it makes sense to tilt your bets towards a drier than normal spring, even a windier than normal spring. Actually, I didn't get into that. I shouldn't open that can of worms, but drier than normal spring if La Nina remains in place. I think as we get into the later parts of spring, as that begins to break down, particularly for parts of eastern Colorado, may not be as reliable an indicator. And then early summer outlooks suggest an increased chance of warmer than normal, largely based on trend, and a slight tilt towards drier than normal conditions. Okay, thanks. If you have any questions, please feel free to follow up either now or over email later. But again, thanks for having me and enjoy the rest of your meeting, I suppose.
Thank you so much, Peter. It's good to have you back with us. In case you
Yeah,
all
it's good
didn't
to be
know,
back.
yeah, Peter was on paternity leave, so we're glad to have you back now. All right. Thank you for the thorough presentation, Peter. I'll just open it up to questions from the audience or in the chat. Peter, I have a question for you. Are there any maps like you have for the El Nino and La Nina for the seasonal, wetter or drier than average just for neutral conditions? Or I guess if we're going to enter into neutral conditions, like, is there anything that we should know?
Yeah, it's a good question. I would have to dig into things a little bit more
Okay,
because it's not necessarily a linear relationship, right? It's
gotcha.
possible to have areas where you do statistically have an increased probability of above or below normal precipitation conditions. In general, we don't have, if that is the case, it's probably either because um, La Nina is really bad or El Nino is really good, something like that. So as long as you have like not Nino or not Nina, you can say something, not because there's something particularly special about neutral conditions. In general, neutral conditions just lead to more uncertainty. They give us less of a leg to stand on.
Okay,
Yeah.
thanks. All right, any more questions can be put in the chat. We will move on to our presentation from NRCS.
Awesome. Hi, everyone.
Hello.
Screen. All right. Emily, can you see my screen?
Yes.
Okay. Awesome. Yeah. Hi, everyone. I'm Nugam with the NRCS Snow Survey Data Collection Office. Hydrologist on the team. Brian DeMoncos is our supervisor. He typically gives these presentations. Our team's out in the field this week for our monthly manual snow surveys. So he's out in the field. Those snow surveys are used for first of month forecasts and then to validate our SNOTEL data. So yeah, they're out there getting measurements this week. So. Okay, so to start things off, I have two dates here. Statewide conditions as of 2/24 and February 13th. So the significance of that was that President's Day weekend storm that started on the 13th and kind of lingered for a couple days. So and the graphic, the image on the map on the right is the snow water equivalent totals for that storm system as well. So we can see that the whole state benefited from that storm, and it was pretty high density snow in the southwest. We had totals up to 3.6 inches in SWE, like Mancus and Shark's Tooth, SNOTELs, and then in the northern part of the state, 3.8 inches. So yeah, it was the whole state benefited from that. Snow water equivalent as of the 24th after the storm stands at 102%. Water year to date precipitation was boosted to 104. 30-day precipitation to 109%, 60-day to 104, and then prior to that, and these numbers aren't too far off from the first of month values as well, but prior to the storm on the 13th, snow water equivalent was at 90, water year to date precipitation at 94, 30-day precipitation at 55, and 60-day at 75, and that's you'll see here shortly reflective of the drier conditions that we had in the month prior in January, just statewide. Soil moisture, those are actually pretty good. The both 8-inch and 20-inch, the deeper sensors range up to 149, 148%. And then the lower values are at 51 and 47. Generally, soil moisture in southern basins are in the higher saturation ranges, and that's related to the wetter start to the water year that we had in October and November, and then the end of water year 2024, we had a really active monsoonal season in the southern basins as well. The South Platte, however, is a little bit drier, so it's reflective of those lower percentages in the 51 and 47%, just because that basin had little to no precipitation at the start of the water year last year, or yeah, this water year, sorry. So this map here on the right is statewide snowpack as of the 24th. So again, at 102%, we can see pretty clear north-south divide here. The southern basins ranging from 69, 70% to 89, northern 100 in the Yampa, White, Little Snake to 109 in the South Platte. So the storm during President's Day weekend boosted, definitely boosted those southern basins a bit, but not as much as we would have hoped to make up for those deficits in January. Some of the graphics here on the left represent snow water equivalent February 24th versus this time last year. So the purple line bars are for this year, and it's a mixed bag overall. Not too drastically different. I'd say the combined southwestern region is probably has the biggest variance, as does the Upper Rio Grande. So those are at 70 percent of median compared to 89% of median last year for the San Miguel, Dolores, Animas, San Juan, and for the Upper Rio Grande, currently at 69% of median compared to 85% this time last year. The bottom graph just shows that percent change for the same time, again showing those two southern basins having the largest percent change and the South Platte benefiting the most. But when we look at this overall statewide, not too much of a percent change. So that's good, and that's largely because the northern basins have been making up for that deficit there. Okay, so getting into precipitation, water year-to-date precipitation is at 104%. Again, favoring northern water systems, with the Southwest kind of lagging behind. And the graphic on the left will show statewide precipitation percent departure from normal. So in October, it wasn't too far off from zero, but a bit of a deficit. November was good overall for most basins, but then we got into December and January with larger deficits, and then storm cycle started to pick back up in February, so that deficit decreased a little bit. Okay, this is month-to-date precipitation. So February 1st to February 24th, which is at 133% of median. Again, northern basins having higher percentages, ranging from 130 in the Colorado headwaters to 149 in the Laramie and North Platte. And similar trend for the southern basins, as previous data shows. So Upper Rio Grande's at 59%, showing the larger deficits, and then San Miguel, Dolores, San Luis, San Juan at 75, Arkansas at 74. The graph on the left is statewide precipitation by month. So I have median, historical medians in the yellow bar, and then current year in the blue. So for October, we started off pretty strong for the water year. November lagging a little bit behind. Oh, sorry. So no, yeah, October was good, not too far off from median. November, significant improvements above median, and then December we dropped a bit, and January again a little lower than median, and February back closer to the historical median. This is the 90-day precipitation map, and it shows that we're at 94% of median. And again, northern systems benefiting here. The image on the left just shows seasonal precipitation distribution by median accumulation. I put this together particularly for the Upper Rio Grande and the two southwestern basins, southern basins, San Miguel, Dolores, San Luis, San Juan, just to show like how the seasonal precipitation is accumulated throughout the season. And November through April usually accounts for like 55%, which is critical because we need that. We need that snowpack for agricultural producers and available by like May and June. However, we do have a decent amount that falls in the summertime and during monsoon season. So I just wanted to highlight that as well. So approximately 30% in June to September that falls as rain. October largely falls as rain as well, and that's about 8%. And May, probably a mix there between rain and snow, and that's about 7%. These are our AWS precipitation accumulation graphics for, this is for the San Miguel, Dolores, San Luis, San Juan, and the black line highlights our current water year. The green line is the median, so we can see that we're below it, and I highlighted some similar years here. So the orange line is 2014, and then the red line is 2006. So we're kind of trending with those two. The bottom projection, it highlights various projections from like 10% to 90, and then there's a min and a max as well. And the solid green line is the median again. So the 50% projection is still below the median here. If we were to look at the 90% projection, if conditions end up being a little more wetter, the 90% projection would likely, that would put us up with the median. Similarly, this is same graphics, but for the Upper Rio Grande. This years that are similar for this basin are 2003, which is the purple line on the top graph, and then 2014, which is the orange line. So we're kind of trending with those, still below median there. And again, if you look to the bottom map or bottom image, the projection for that's similar to the median is, again, it's between the 90 and the 70. That would put us closer to the median. So that would be if we have improved conditions and sustained storm events. Okay, moving on to reservoir storage. Statewide reservoirs are at 90%, and that is a 3% increase compared to this time last year, which we were at 87%. The main water systems that are kind of lagging, as we know, are the southern basins and southwest western slope area. So in the San Miguel, Dolores, San Juan, McPhee is, if you look at the bottom departure graph, the purple line, I'm sorry, actually the gray line is the San Miguel, Dolores, San Juan, and we can see that has departed from the median. McPhee is at 55% capacity and 77% of median. And Navajo Reservoir is at 61% capacity and 79% of median. I just highlighted those ones because those are the larger capacity reservoirs in that basin. So not too far off, not too bad from like normal, but still well below normal. In the Gunnison, that is the purple line in the departure graph, also kind of bringing down the overall statewide reservoir median, and Blue Mesa is the larger capacity reservoir there. It's at 62% and 95% of median. Okay, so moving on to soil moisture. On the left, we have 8-inch soil moisture and then 20-inch soil moisture on the right. So again, yeah, the soil moisture conditions overall are really not too bad, with the exception of the South Platte, which is at 70% for the 8-inch and 94 for 20-inch sensors. Laramie and North Platte is at 53% for soil moisture at the 20-inch level. And then everything else isn't too bad. You can see some pretty high values in Arkansas and the Upper Rio Grande, and generally on the western and southwest slope. And that is largely due to the active monsoon season that we had last year. Okay, moving on to stream flow forecasts. So forecast overall dropped February 1st from January. So on February 1st, the 50% exceedance probability is now at 89% and was at 98%. This is kind of expected. During the start, the earlier forecasts usually, or as the season progresses, the accuracy improves as those input variables, as they get more information, like with snowpack and precipitation, and then antecedent stream flows and other input variable. But yeah, as the snowpack builds, the accuracy improves. So the largest drop was in the southwest, so 74% in the bottom corner, and the Upper Rio Grande, we are at 86% for 50% exceedance probability, and then the Gunnison's at 87%. It was a little higher in January also because we had a really strong start to the season in October and particularly November in that southwestern corner. This is a forecast exceedance probability for the San Miguel, Dolores, San Juan, and I just put a little blurb here just because, during for drier or wetter conditions, it's important to consider the full suite of exceedance probabilities as possible probabilities. Sometimes it's easy just to hone in on that 50% as a primary reference, but definitely good to consider the 90 and then, up to 10% if conditions, depending on future conditions. So I'll just walk through this real quick, but the gray line here kind of on the right side of the probability image is the median, and you can see that in green letters. And then the black bolded values, those are the 50% values. So we can see they're all below the median. However, that could vary just depending on future weather events, which is the largest source of uncertainty. So again, just important to really consider this full suite, especially where the spreads are a little bit bigger. Like Mancos River near Mancos, we have a larger spread there, and that's just for various reasons, diversions and such. So yeah, just plug there to consider, the 70%, all of them as possible outcomes. This is a exceedance probability for the Upper Rio Grande. So some larger spreads here. We have the Sangre de Cristo Creek, which ranges, from 3.6. This is in 1,000 acre feet. You can also, there's an option on our webpage on the NWCC apps webpage to change this to median if anyone prefers, but this, for the purpose of this presentation, it's in 1,000 acre feet. The Culebra Creek at St. Louis also has a large spread. So yeah, just be mindful of the various outcomes there. The Gunnison, let's see here. Gunnison River near Gunnison is at 280, so below median. And and then Gunnison River near Grand Junction also has some higher values. That 50% probabilities at 1,010. The 70% exceedance is at 800. This is a snow water equivalent projection for statewide conditions. Peak is roughly April 8th. Our median peak is April 8th. So we still have some time until then. And yeah, again, future weather will certainly impact those forecasts that we were just looking at. But if we look at the 50% projection, that puts us at about roughly 14.6 inches of snow water equivalent come April 8th, and the median's at 15.4. So the projection, the 50% is still slightly below that, but again, depending on future weather, the 70%'s at 15.9. So just some things to be aware of and outcomes to consider there. Okay, so in summary, statewide snow water equivalent was boosted by those mid-February storms from 90% on the 1st to 102% on the 24th. Statewide water year-to-date precipitations at 104% of median, so ranging from 77% in southwestern corner to 104% in the South Platte. Month-to-date precipitation is 133, showing a clear divide with northern water systems being favored and southern water systems ranging from 65 to 84%. Reservoir storage is at 90% of median, a 3% increase from this time last year. Soils are generally setting pretty well. and indicate high saturation percentages across southern basins due to that strong monsoon influence at the end of water year 24. And then in contrast, some northern regions received minimal late summer precipitation and remained out drier, like the South Platte. Statewide stream flow forecasts have declined, but that is expected. Just, well, not expected, but it's not necessarily a bad thing, but have declined from January to February, with the 50% exceedance probability dropping from 98 to 89%. Forecast accuracy is lower early in the season and improves as more snowpack data becomes available. And again, future weather remains the largest source of uncertainty here, so it's important to evaluate the full range of exceedance probabilities, especially in those dry regions. And that is it for me. I will take any questions if there are any.
Okay, thank you, Nagam.
Thank you.
Yeah. All right. Well, we've come to the end of our presentations. I will now open it up to any water providers, municipalities, or utilities on the line who might want to update us on conditions in their local area. So feel free to come off mute or put your update in the chat. Any takers today? I see John's on the line and Swithin.
Okay, this is John Orr Thornton, and I was going to put it in chat, but you called my name. So,
Sorry.
storage for Thornton is our last weekly report was just over 77%, which is pretty normal. And we're if the snowpack hangs on, we're fairly confident that we will fill this year. But of course, who the hell knows if what's going to happen between now and the end of runoff season. I'm looking for this workbook that I opened up. Sorry. Okay, well, production is about the same as last year. It was 2% below on the last report I saw. So that's essentially, equal. We're doing okay there. And we're in drought watch still because there's drought in our, still in our watersheds, or at least in the Poudre. And our drought management plan calls for drought watch when we have drought in our watersheds. So that's my report.
Thank you so much. Anyone else? I see we have Castle Rock and Aurora and Denver. All right, hearing none, I will end the February 2025 WCMC meeting. Thank you all for being on, and our next meeting will be on March 25th. So I'll see you then.